Okay, let's look at this graph over here to get an idea of where we're headed. Here's the original function graphed on Desmos in red, and I've put rows in here for f of something very close to 0, and it looks like it's negative 0.06249, and I could add more zeros and even get closer to this value right here, negative 1/16. And of course, there is an open circle here. There's a hole in the graph at that point because the way the function is defined, I can't divide by 0, so x cannot equal 0. The question is, how do we figure this out without looking at a graph? And basically what you would like to do with this kind of problem is get a common denominator for these two fractions in the numerator and just see if you can simplify it and get this x in the denominator to cancel out. Another way to simplify a complex fraction is to multiply numerator and denominator of the big fraction by the LCD of all the little denominators, which is the method I prefer. So I'm multiplying by the number 1, so I'm not changing the value of the original function, I'm just changing the way it looks. Now I could continue down here and keep writing the limit as x approaches 0, but I'm going to leave that off till the very end. I multiply 4 times the quantity x plus 4 times each term in the numerator. For this first term, the x plus 4's cancel out. I'll have a factor of 4 remaining. 4 times 1 is 4. If I take the LCD times the 1/4, the 4's cancel out, and I'll have minus 1 times x plus 4. And in the denominator, I don't even have a fraction, I just have this x. So 4 times x plus 4. And when I simplify that numerator, I get 4 minus x minus 4, which these just 4 and negative 4 are opposites, so they cancel out. And now this factor of x in the denominator cancels out with this x in the numerator. And so I've got the limit as x approaches 0 of negative 1 over 4 times the quantity x plus 4. Now when I try direct substitution, I don't have a problem. There's not a 0 in the denominator. So I get negative 1 over 4 times 4 is 16. So there you go. That's the y value that is approached as x approaches 0 for this function. Hope that helped. If you have any questions, post a comment.